Good morning, guys. Today we're going to be covering 1-7 exponents. So here we go. Let's jump in. It says, in the case of repeated multiplication with the same number, we can rewrite the expression using exponents. For example, 4 times 4 times 4 gives us 4 to the third. So the parts of an expression, okay, the bottom, the number that's being repeated, multiplied, is called the base. The small little number on the right-hand corner, that is called the exponent. It is read as x to the nth power. So this 4 would be read as 4 to the third power, or we can shorten that because it's a 3, 4 cubed. Okay, so now we're going to work a couple of examples. Okay, so we're going to jump down to number 3. I'm going to look to see how many times is this written. 1, 2, 3, 4, not written, multiplied. This is 4 times, so this is going to be -5 to the 4th power is the way this is written. Now, we need to actually value. Okay, we need to find what the value of that is. So we're going to write a little note here. So we can say to find the value, simplify all the way. Okay, so for right here, I'm going to do some work. That means I'm doing -5 times -5. So when I'm looking at this, I can multiply these two together and these two together. So that's going to give me a negative times negative. That's going to give me 25 times 25. So right here, I'm going to do that math. 25 times 25. So I'm doing long multiplication. 5 times 5 is 25. Carry my 2. 5 times 2 is 10. Plus 2 is 12. Now I'm multiplying by the 10. So I'll place my 0 to hold the spot. 2 times 5 is 10. Carried my 1, 2 times 2 is 4, plus 1 is 5, so I add, and now we have 5, 2, 6, so my answer here is 625. All right, so now when we throw in fractions, this is a little quirky looking, so I'm going to try and focus it, but I don't know that it's going to do much good. I'm sorry for that. I'm looking here, this is the fraction, this is the whole fraction that's multiplied 3 times, so therefore the exponential expression is going to be 1/4 in parentheses raised to the third power. So now when I'm wanting to calculate it, okay, I'm multiplying these two together, so I'm going to do this work right here. So I'm multiplying 1/4 times 1/4, that means I'm doing 1 times 1, which gives me 1, 4 times 4, which gives me 16. Times the third 1/4. And now I continue to follow my fraction rules and multiply across. 1 times 1 is 1. 16 times 4. I'm not sure about that, so I'm coming over here and I'm doing that calculation. 4 times 6 is 24. Carry my 2. 5 times 4 plus 2 is 64. So we now have my value of 1/64. Notice I have calculations for these two. You must show that work. All right, jumping down a little bit more. So we've worked 3, 4. Now we're going to work 9 when we're pulling in the letters. Okay, so I'm looking at what am I repeating? Let's zoom in this a little bit more so it makes it not as blurry. I don't get why it's not having a good morning for me. Didn't make much difference. But the XY is what's repeating, and it's repeating 1, 2, 3, 4, 5 times. So that's the whole thing. So in parentheses, I have X times Y to the 5th power. There's not a value for this. There's no numbers to plug in here, so I don't have to write an answer here. All right, next example. We're going to jump on down to 14. Okay, so we're pulling multiple things together here. Okay, I'm looking at each thing separately. So I've got the 6's, Okay, kind of like I'm doing combining like terms. I've got 1, 2, 3 6s. So I'm going to have 6 to the third power. And then I'm looking at the expressions that I have that are inside the parentheses. How many times do I have that? Twice. So I write that in the parentheses, a plus b parentheses squared. Now, I can't do anything with the a plus b, but I can do 6 to the third. So I'm going to come over here and I'm going to have 14. And since I'm doing 6 to the third, that's 6 times 6 times 6. These two together equals 36 times 6. 6 times 6 is 3, 18, 21. So I'll get 216. So we have 216 open parentheses, a plus b close parentheses squared. And there's my answer for this page. All right, now we're going on to the second page. This is where we're pulling into some kind of special scenarios when it comes to exponents. Okay, this is where in the video, the pre-teach video, it explained this very nicely. Anything, okay, okay, any number except 0 raised to the 0 power is defined as 1. It doesn't matter what it is. 1 to the 0 is 1. 2 to the 0 is 1. 3 to the 0 is 1. 4 to the 0 is 1. But x to the 0 is 1. Anything except 0. When we have 0 to the 0, it is called undefined. Okay? It is called undefined. All right, so now we're going to work a couple of these problems. Okay, we're writing each expression. Oh, negative. Forgot about that. So 0 exponent rule is pretty much, it's anything raised to the 0 power equals 1. So a little note here. Anything raised to 0 equals 1. Negative exponents. Okay. For the negative exponent rule, okay, that means you bring it to the bottom. So this is going to become 1 over x to the n. My little note to remember this, okay, move negative exponent to bottom to make positive. That's the way I remember it. So let's look at a couple of examples. I'm going to zoom in a little bit more so it shows that negative actually on the page. All right, so if I have 5 to the negative 2, to make that negative 2 become positive, I move it to the denominator because right now this is a fraction that has 5 to the negative 2 over 1. So I move it down. So it's now going to become 1 over 5 squared. This is the exponent or exponential form. Now the value where I actually work it. So that means it's going to become 1 over 5 times 5, which gives me 1 over 25. This is the value, which is where you evaluate. This is the evaluate. Positive exponents is this answer here. So in a way, you have 2 answers for each problem. For some problems, if you're dealing with numbers. All right. Next example. 21. So that was 15. So we're going to move down here to 21. So I'm going to first step is to change to positive exponents. Okay. First, change to positive exponents. All right, so this is going to become 1 over 4 to the third. I don't like to use the dot because it makes it too much like a decimal, so I'm going to put in the parentheses 1 over 7. I do not have to write this first power, the 1 there. It's understood to be there. All right, so now I simplify because this is the exponential form. Now we need to actually simplify. So I'm going to have 1 over 4 times 4 times 4 times 1 over 7, which is going to give me much room here, so I'm going to actually have to do the calculations of the 4s off to the side. This gives me 1 over 64 times 1 over 7. So we did, this is 21, 4 times 4 times 4, that's 16 times 4, which gives me 64. And now I need to do times 7. 7 times 4 is 28, carried my 2. 7 times 6 is 42, plus 2 is 448. So we end up with an answer of 1 over 448, and that's my value. Okay, moving on down to ones that deal with letters. Okay, so we have 25. We treat the same way. I take the exponent and I move it down. So this is going to become 1 over x to the 9th. And I can't go any further because I'm just dealing with letters. All right, looking at 27. Okay, this is where if it's a negative exponent, I move it to the bottom. The r here is the only one with a negative exponent. So that's the only one that's going to be moving to the bottom. The rest are positive. Ooh, when I look at this, this is s to the 0. So therefore, I'm going to now have r 1 over r to the 6th, s to the 0. Remember, s to the 0 is going to equal 1. So now I have times 1. And then I have t to the 11th still at the top. To make that a fraction, I can put it over 1. And now I work it. So I have 1, if I want to, I can make this into a fraction. So I have 1 times t to the 11th. So that's going to give me t to the 11th over r to the 6th times 1, so that gives me r to the 6th in the bottom. There is my final answer. Your assignment is to finish unworked notes problems. Thank you.